I want to factor this. You don't have to rewrite yours. I'm going to rewrite mine because mine is ginormous, okay? And so I'm going to rewrite this 2x squared minus 15x minus 8, but you don't have to rewrite yours yourself. Factoring is so important. It is going to be within so much of what we do this year, and it takes practice. You can't just watch me do it in class and think you get it. Like, it's something that you have to practice on and make sure you get. Hopefully you remember from a quadratic, and you don't necessarily have to write this down, but this is ax squared plus bx plus c. So we always refer to the x squared term, the coefficient is a, the x term is b, and then your c. So here I have this a. My a is not 1, okay? So I am going to I'm going to make this into something I can do grouping with. We did grouping yesterday, right? But we did grouping when we had 4 terms. I don't have 4 terms, so I'm going to make it into 4 terms, all right? So what you do is you're going to multiply a times c. So I'm going to do 2 times a negative 8. That gives me a negative 16. Okay? I need 2 numbers that are going to multiply to give me negative 16 and add to give me a negative 15. And I got that negative 15 from right here. You with me? Okay, you always do a times c, and because you're multiplying them, you need 2 numbers that will multiply to give you negative 16 and add to give you this one. Now, since I need to multiply to give me a negative, that means the numbers that I come up with have to have opposite signs. That's the only way I'm going to get a negative number, right? So we go through the factors of 16. Well, 4 times 4, that's not going to work because if one of them is negative, I get 0. If I get 2 times 8, that's going to be like 6 if I subtract them. What's another option? It's another factor of 16. 16 and 1. So if I do 16 and 1, those multiply to give me 16, but I need it to multiply to give me a negative 16 and add to give me a negative 15, so I have to decide which one of these is negative. Which one? The 16. So negative 16 and 1. You see how we came up with those numbers? Okay. Okay, there's a charger. Is he using? There's another one somewhere. There's one over there. You pulled it. Where'd it go? Oh, it's just rolled up, so you just have to unroll it and pull it over. Okay, so now we are going to split this middle term into these 2 things we just came up with. So this is going to give me 2x squared, and then not a negative 15, a negative 16x plus x. I'm going to leave off the 1 because that gets confusing, minus 8. When you get to this step, okay, I was helping somebody with this earlier today, and they were like, every time I keep getting my signs mixed up. Well, they were getting the numbers correct here, but then here they weren't putting the signs right. So you can double check that you're right. These 2 things should always add back to give you this. If it doesn't, don't go any farther because you're not going to get anywhere. Make sense? Okay, so now we have 4 terms. Now it's grouping just like it was yesterday. I take these first 2 terms and I factor out the GCF. What's the GCF of that? 2x. Very good. And then that leaves me with x minus 8. Then I have to look at these 2 terms. Well, there isn't a GCF, so what do we factor out? A 1. It's like the only time you actually factor out a 1. So then I get plus 1, and then I get this x minus 8. If you get to this step and your 2 little parentheses sets don't match, something was wrong up above, probably a sign or something, okay, because they should always match. So then at this point, look at me leaving off my equal signs after I told y'all to make sure you have them. I'm going to factor out my parentheses here, so x minus 8, and when those are gone, that leaves me with 2x plus 1. And that is my factored form. When you're done, you don't have to, but you can check yourself. Make sure that negative 8 times 1 gives you a negative 8. Make sure that 2x times x gives you 2x squared, right? And then make sure when you get this negative 16x and a positive x, get you there. So you can always check yourself when you're done to make sure you're good. Okay? What questions do you have? You got this? It's not that bad. It's a process that you got to be able to get through. And as long as the more consistent you are, the better off you're going to be, and the easier it's all going to be. Okay. All right, so let's go to the next one, slide 8. All right. So once again, I'm going to rewrite mine because mine is ginormous for some reason. So I've got 9x squared minus 12x plus 4. So the first thing I really want to look for anytime I factor is a GCF, because if I have a GCF and I can factor it out, it makes my numbers smaller a lot better. This one, unfortunately, doesn't have one. So since a is not 1, I'm going to multiply a times c. What's 9 times 4? 36, and it's a positive one. So I needed to multiply to give me 36 and add to give me a negative 12. If this is positive, the signs on my numbers have to be the same. Since this is negative, both numbers have to be negative. Okay? So what would those two numbers be, do you think? Well, let's write, well, you start thinking, what are my factors of 36? Well, I've got 4 and 9. I know that for sure. That's where it came from. Then I got 6 and 6, and I got 3 and 12. Okay? I'm adding them, and as long as they're both negative, these are my numbers right here, negative 6 and negative 6. Okay? So instead of staring at it, just start writing them down, and then other ones might just come to your mind. Okay. So now we're going to split this middle term, right? So I'm going to get 9x squared minus 6x plus 4. Then you're going to factor by grouping. Go ahead and see if you can finish this. Did she do it? Yes. It starts tomorrow? Yeah. Okay.
She said if you counted me present, I could just go.
You can go. All right, you're good. All right, see you later. Phone died. Okay, so, I thought that was a parenthesis. Never mind. I was going to tell you to do something else, but. All right, guys, you can't just sit there and stare at it. Okay, out of these first two terms, you can't factor a 9 out of that. How do you get a 9 from a 6? Oh, yeah? Okay, these first two terms here. What's your GCF? Out of the numbers, the biggest number I can factor out is a 3. And I can factor out an x. That leaves me with 3x minus 2. Out of these two, if this is negative, I want to make sure I take out a negative. I can take out a 2, and that leaves me with 3x minus 2. Yeah? So then once I'm here, I get 3x minus 2 when I factor those out, times 3x minus 2. Is there another way to write that? How? Very good. 3x minus 2 squared. What questions do you have? All right, good deal. Then I want you to do this next one all on your own. You're not even doing the right thing. Don't act like you were doing that. I know that you weren't. Factor that. And you know what makes all this a lot easier is if you know your multiplication facts, so you can come up with those numbers. Good job, Leo, Adrian V. Okay, my numbers are 8 and -3. So it gives me 12y squared plus 8y minus 3y minus 2. All right, so then we factor out of here. I can factor out a 4y. That's going to leave me with a 3y minus 2. Out of these two, I can factor out a -1. Leaves me with the 3. Oh, that should be plus 3y plus 2. So in the end, I get 3y plus 2 times 4y minus 1. There you go. What questions do you have? Anything? We good? You can factor if A is not 1? All right, so now I want you to go back to slide 1 on this. I'm going to go all the way back to the beginning. All right, so here's one where A is 1. Those are a lot easier, but what some people fail to recognize is that you don't have to do grouping here. It's the same thought processes from the beginning, but you don't have to actually group. So A is 1, so I got 1 times 45 basically. is 45. I need it to multiply to give me 45 and add to give me 14. If they're both positive, then both values have to be positive. What are they? 7? 9 and 5. Got to multiply to give me 45. So 9 and 5 will multiply to give me 45, add to give me 14. So instead of grouping here, like I don't have to split this middle term because I already know what my numbers are and there's nothing here. All I have to do is put my x here, my x here. These are the numbers that go here. 9 goes here, 5 goes here. Positive 9, positive 5. You're done. That's it. No reason to split anything. Only do that if A is not 1. Otherwise, you're doing extra steps you don't need to do. It'll waste your time and your brain cells and your frustration, and there's more room for error. Okay. We good? Then always check yourself. Positive 9, positive 5 gives me 45, because sometimes those things don't work. All right, let's do the next one. So here I've got x squared minus 15x plus 26. So I need two numbers that are going to multiply to give me 26 and add to give me a negative 15. Well, luckily 26 doesn't have that many factors, right? It's 1 in 26 or 2 in what? 13. So 2 and 13, but I have to make some sign decisions here. This is positive, so that means that the signs have to be the same. So that means both of these are negative. That's how I get my negative 15, right? If A is 1, I can go ahead and say, all right, I know I'm going to get two binomials, x, and I know that if this is positive, the signs have to be the same. This is negative, so they're both negative. And then all I have to do is plop in the 2 and the 13, and I'm done. And that's it. Okay? We good with that? All right, you try the next one on your own. Adrian Reyes, just rewriting it isn't good enough. You need to get it factored. Oof. Some of us need to learn our multiplication facts. This is painful. Okay. So here's what I know. I know I'm going to have two binomials. This will be y, this will be y. Since this is negative, the signs are opposite. So one of them is positive, one of them is negative. I need two numbers that are going to multiply to give me a negative 48 and add to give me 2. So my factors of 48, I got 1 and 48, I got 2 and 24, I got 4 and 12, I got 6 and 8. I think that's about it. But I know already that the signs have to be opposite. So basically they're going to have to subtract to give me a positive 2. So what are my numbers? 6 and 8. And which one is positive? 8. So it's a positive 8 and a negative 6 because I need a positive 2. Instead of staring at it, just write down, I mean, you could write down all your factors and be done with it by the time you stared at it forever trying to figure out the best. Okay, that's your answer. You're done. Okay, we good with that? All right. So let's step you through one more. See if we can get through this a little quicker here. Here are the things I want you to do. We've got n squared minus n minus 72. And the more consistent you are, the better off you are, I promise. So you know since a is 1, you're going to have two binomials. N is in one, n is in another. This is negative, so what does that tell you about these signs? They're opposite. So one's positive, one's negative. So then I come over and go, all right, 1 times negative 72 is negative 72. I need it to multiply to give me negative 72 and add to give me negative 1. If you can't just think of what it is, list things out. Well, I got 1 and 72. I got 2 and 36. I got 6 and 12. I got 4 and 18. And I got 8 and 9. I think that's all of them. Would any of those, since the signs are opposite, subtract to give you negative 1? 8 and 9. Here are my numbers. Which one's positive, 8 or 9? 8, because I need it to be negative, and there it is. Don't just stare at it, just write stuff down. And if you just start writing things down, it'll probably be right in front of your face there. Okay, we good? Questions? Okay, you got one more you're going to do on your own. You're going to do the next one on your own. Kind of feel like deja vu here, huh? So two numbers that are going to multiply to give me 36, add to give me 12, and I know that I've got A and A. This is positive, so the signs are the same. This is positive, so they're both positive. Is 6 and 6. So this gives me A plus 6 squared. Okay. We good? What questions do you have? All right, I want you to go back to yesterday's notes and open those back up because we skipped some things that I want to go back to today. I'll have to figure out what slide that's on. We'll see what I can figure out. So on yesterday's notes, the day 1 of factoring, I want you to start with slide 4. That's where we're going to start. I gotta finagle this a little bit because I didn't open it back up. Yesterday, it should say 0.3 factoring day 1, something to that effect. Yeah, I don't know why the order that they're in there like changes sometimes. So I'm trying to be consistent. So it looks like this, but we did a lot of it. We're going to start with the sum of cubes, and for you to get to here, it should look like, it should be slide 4, I believe. Is that right? And it won't let you do, oh, shoot. Okay, hang on, let me go in. I thought I put them where you can, so I probably have to do something. Oh, yeah, it said no edits, I'm sorry. Allow edits. Okay, you may have to refresh, but it should let you do that now. I thought I changed that on all those. So yeah, if you got in there but it won't let you do anything, will you now? You're good now? Okay. Thank you. Sorry about that. Okay, so sum of cubes. Now, sum and difference of cubes, you have to know the rule to do it because that's really the only way to do it. So our perfect cubes, talk about what a perfect cube is. Perfect cube is like 1, 8, 27, 64, 125, 216, so and so forth. So this is 1 cube, 2 cube, 3 cube, 4 cube, 5 cube, 6 cubed, and so forth. Okay, those are what perfect cubes are. Our rule for factoring a sum of cubes would look like this. A cubed plus B cubed. You have something that's cubed plus something else that's cubed. When you factor it, you're going to get a binomial and you're going to get a trinomial. Okay, we're going to put the pieces in there first, then we'll talk about the signs. You take the cube root of each one of these. So the cube root of A cubed is A. That's at the beginning of that one. The cube root of B cubed is B. That's how we get that. Okay? It says 0.3, factoring day 1, right there. Okay. So then there's 3 terms that go in here. We'll come back to the signs. You take this, whatever this ends up being, and you square it. So this is A squared. In the middle, you have these 2 multiplied together, A times B. Your last term is this one squared. You see how easy that is? It's a pretty simple pattern. Now let's talk about how to get the signs in there correctly. We use this acronym called SOAP. That stands for same, opposite, always, positive. That's how you get the signs in the right place. Same, opposite, always, positive. So same means it's the same as whatever, like if it's sum or difference. So since this is addition, my first sign is the same, the next sign is opposite, the last one is always positive. That's how you get the signs correct. SOAP. All right. So let's look at number 7. This is h is cubed, and then 125 is a perfect cube. So the way you want to start off, so that you don't mess things up, is you get little parentheses, big parentheses, and leave yourself enough, like a lot of room. I never leave myself enough room. Then the next thing I'm going to do is put my signs in there, so I don't mess those up. They are the same, opposite, always positive. Then I'm going to worry about what actually goes in there. The cube root of h cubed is h. What's the cube root of 125? 5. Okay? Now what goes in here comes from this. I take this first one and I square it. It's h squared. Then I multiply the 2 together, so I get 5h in the middle. The sign's already there. I'm not worried about it. And then the last one is this one squared, and I get 25. That's it. You're done. See how easy that is? It's really not that bad. You got to know the pattern, and remember SOAP, and you're golden. Okay? So let's do number 8 together. This is a cubed, and this is cubed. So I'm going to start off with little parentheses and big parentheses. Then I'm going to get my signs. Same, opposite, always positive. What's the cube root of 8f cubed? Well, I got to take the cube root of 8 and the cube root of f. So what's the cube root of 8? 2. So this will give me 2f right here. The cube root of 27 is? So what times what times what gives me 27? 3. Okay. So now that I've got those filled in, then I square this. What is 2f squared? If I square this, 4f squared. Good. Then this one, I multiply these 2 together, so I get 6f. And then this one is 9. And that's it. We good? All right. So let's see if we can factor this one. We're going to factor out the GCF first, because I can, all right? Even though 27 is a perfect cube, there's a GCF here. So what do you think the GCF might be? Remember the 3 trick we talked about? First of all, is 27 divisible by 3? Yes, we know that. Is 512 divisible by 3? Remember how to look at that? You add the digits, so you've got 5, 6, 7, 8. Oh, it's not. Oh, then we don't want to do this one. Okay, let me change this. Let me change this number to 125. I was looking at that wrong. And then I want you to do that one. Okay, change that to 125. We don't need to go crazy with those. I couldn't add 5 plus 1 plus 2 correctly. I got 9 the first time I did it in my head. Oops, I'm on the wrong one. Good. See, some of you are setting it up like I told you to. That's good. Some of you still are not on task. Mr. Reyes, do you even know where we are? You hadn't even written anything down. How are you supposed to know what to do? Dude, you don't just get to sit here and play on your phone the whole time. Okay. So, the cube root of 27a cubed is 3a. Do we agree with that? Cube root of 125 is 5, right? So then here we square this one. That gives us 9a squared, right? Then this one, we multiply these two together, which gives us 15a, and then this is 25. What questions do you have? You got it? Not that bad? All right, good deal. Then let's go ahead and move on. Let's talk about the difference of cubes. All right, difference of cubes. Here's our rule for factoring. So we're subtracting them instead of adding them. So we have an a squared, no, we don't because that's squared. We have a cubed minus b cubed. So here's what remains the same. What remains the same is you end up with a binomial times a trinomial. The other thing that remains the same is what goes in the spaces, not the signs with the spaces. So I take the cube root, this is still a, this is still b. Here I still put a squared. In the middle, I multiply them together. At the end, it's b squared. So that pattern is exactly the same whether it's sum or difference of cubes. That's awesome. And we still use SOAP for the signs. Same, opposite, always positive. So that what changes are the signs. Since this is a negative sign, it's the same, opposite, always positive. So the pattern's the same, and just remember SOAP and you're good. So it's not really 2 rules that you're remembering, okay? And if you start off by putting the signs in there to begin with, you don't even have to think about them. So if we start off and say, all right, I'm going to have a binomial and a trinomial. This is minus, so my signs are the same, opposite, always positive. Then I do the exact same thing I did for sum. The cube root of x cubed is x. What's the cube root of 343? I'm just going to tell you because it is a perfect cube, and you might have to guess and check some things, but it's 7. So it's 7, just so we can move on. Then you fill out the rest of it. And I don't think I put it on your calendar, but you have a quiz over solving absolute value equations tomorrow. And here's the thing with this one, because I saw somebody making this mistake today, so I want to point this out. When you multiply these two together, I know this looks like a -7, but you've already put your signs there and you're not changing them. So you're multiplying the 7 times the x, you ignore the fact that that's minus, so this is just a 7x, okay? So that's why it's good to go ahead and put your signs in there and then don't change them, so you don't make a weird sign thing, and then 49. Okay? We good with that? Because honestly, most errors that are made, unless you just completely don't know what you're doing, they're stupid errors like sign errors that are frustrating to yourself. I mean, I do them too, and so we want to avoid those. All right, you do number 12, and then we'll be done. You do that one on your own. Because you didn't turn your other one in?
No, I turned it in. But the lady, the technician, she said Raven's like all everywhere.
Oh, so it doesn't show that you turned it in? So until they find it, you have to pay for it? Well, the good news, if they find it, yeah.
But like that's what I turned in.
Yeah, I don't know what to tell you. I'm sorry. Don't just wait for me to do it. Good job, Leo. Adrian, let me see your, let me see what happened. So, the signs are same, opposite, always positive. This should be negative. Oh, sorry, I didn't mean to write on it. And then also don't switch the order. Like, you can't put the variable first just because you want it to be first. I'd rather it be first also, but. All right, so I take the 5 and I square it and I get 25. And then I multiply them together and I get 10v. I square that and I get 4v squared. Okay. What questions do you have? Yes, stop. So you got to have some confidence. All right. So your Delta Math assignment that I gave you yesterday, and I told you, I think I put it that it's due like tomorrow or maybe it's due today. I don't even know what I did. But even if it says it's due like today, it's not. But you should start working on it. We're going to work through some things tomorrow with it as well. Give you some work time on that and make sure that we can understand what we're doing. But it'd be better if you got started on it. That way you already know if you have questions and things like that. Okay? Any questions at all? Awesome.